Hello everyone. So if you see, we have this described network virtualization concept, that is LIST, and we have the VXLAN. So these two topic we are going to discuss. This is just theory. Actually we are using this in the service provider and in the data center. So we need to know some basic idea about this one. So let's see. First of all, a LIST, that is LISP. It stands for Locator ID Separation Protocol. This one is using in the what we can say in the ISP network. What we can say LIST is nothing but Cisco locator. Okay, Cisco locator ID separation protocol. It is mapping and encapsulation protocol. So what it is going to map and what he is going to encapsulate, we are going to see that one. Why we are using this protocol, actually why we need this one? Because if you see, nowadays everyone is using the internet. And we have lot of internet routes. On the internet. So we have the issue on the internet router. We are having the more than 8,000 prefix on the internet. So what we are happening with that one? We need to have the powerful router. We need to have very good powerful router with the enough RAM and TCAM to store all prefix. So generally BGP router is a big router which is going to store all the routes, internet routes in the router. Sometime we do aggregation, but some scenario we have disaggregation route also. So internet table is going to fill. We will have the issue. Generally we have the issue because of the more routes, and if we see nowadays we contain more than 800,000 prefix in the internet router. So we have issue. So how we can overcome with this issue? So we are using this locator ID separation protocol to overcome that type of issue. So what we can say, if we can manage this one also. We are managing, many routers are using to manage, but Cisco prepare new solution for this one. So how we can manage means we should have the powerful router with enough RAM and TCAM, so it will be having the good performance of that router. But if you see in the traditional routing, in the traditional IP routing, what we have two things. First thing is we need to identify the device, and second one is the location. We have two things in the traditional way. What we will do, we will identify the device and the location of the device in the network. We use this for routing. So we use routing to identify. Example, if I want to go to 1.1.1, we will check where it is. That is, we are going to identify the device, where it is device, and we are going to check the location. So these two things we are doing in the traditional. But here what we done in the list separation protocol, what we have two things that they separate these two things: endpoint identify and the routing locator. Endpoint identify is nothing but our computer host or the printer, like whatever IP we assign, that is known as endpoint identifier. And routing locator is nothing but it is a router, the router which this endpoint is connected. So this protocol is separated this two functionality of the IP address. If you see this diagram, you will have idea. Example, see this one. Let me show you this diagram. Generally what we will do, this is a small scenario I am giving. If you want to go from here to let me take the pen tool. Okay, so now let me come the pen tool. Okay, so if you see here, if I want to send any traffic, okay, what I will do, if I want to send any traffic, imagine this is my network. If I want to send from here to here, what we will do, generally it will go to our router, and our router will check in the routing table, and he will check where is the next hop, he will forward that, and from here it will go here. This is generally we are doing. Okay, this is generally we are doing. But if we have lot of routes in the internet table, then we have the issue, because this router need to store all the routes in the routing table. And for that purpose, example, if we have 800,000 routes, then we will have the big issue, because it need to be have good capacity, and nowadays also increasing the route, more route we are having. So this router will have the issue. We will increase, we will upgrade, we will have the good router. But even though this is not permanent solution, we have the issue here. So what we will do, we will use the LISP, LISP, this protocol. So in this protocol, what we will do, example, I want to go from this PC to this PC. So what I will do, I will send the packet, it will come here, and here they will send this information to the what we can say mapping database server. We have one server. In that server we will have the entry. If you remember, DNS, domain name system or domain name server, like in CCNA we discussed DNS. What is DNS? Example, imagine you have your mobile phone. In that one you save the number with the name. So whenever you call that name, automatically it will call that number. Okay, so generally what we are doing, we are unable to remember the IP address. That's why we are having the name. Example, if you want to access, I will not say like access 148.10.20. Or 40 like this. I will say just google.com. I will not give the IP, because human beings did not remember the IP address. For that purpose, what we will do, we will use the name google.com, facebook.com. But machine is understanding only IP address. So we are using DNS to convert the name into IP, IP into name. Same like that scenario we have here. We have the mapping database system. In that one, they are going to store. What they are going to store? They are going to store this EID is connected to which router. Example, they will store here, if you want to go 192.168.2.0/24, it is connected to 192.168.123.2. So what they will check, they will come here and they will look that route and they will forward that packet to that router. From there he will forward directly. Let me repeat again what we are saying here. If we are not using the LISP protocol, without this one, what we will do, just we will have the BGP. If we are looking for the internet, and our route will come here, our packet will come here, it will check in the BGP router, and wherever we have route, it will forward, and at last it will go. Imagine this is a Google server. Okay, this is a Google server. So I am accessing the Google server, so it will come to our router. We will forward that to default route to BGP, big router, that is a ISP router. From the ISP router it will check where it is there and they will forward here like that, and it will come here. But now we have the issue because we have more routes on the BGP router in the ISP router. So for that purpose, what they are doing, they are having separate server that we are calling mapping database system. In that one, they are going to store. What they are going to store, example, this host is connected to this router. So they have this entry. So whenever we are requesting here, first it will go to that server, and the server will inform. Example, if you see this scenario, here asking where is this 192.168.2.102/32, where it is, it is asking here. This guy is replying, this EID is connected to RLOC, that is the router, and this is the router IP. So then this guy will forward directly to there. So first they will go to the server, mapping server. From there they will get the information. After that they are going to forward the traffic. So this way we will reduce the routing table here, because we are getting the information from the mapping server. This way it will work, and we can configure this, but we don't have configuration in our what we can say in our syllabus. I will just show you. I don't know, maybe this is available in this router or not. Same like we are configuring router OSPF, we need to write router LIPS. Let me check here, because in the new router this one is coming, but in old router we will not have. Anyhow, let me check. If I write router and press question mark, we will see. If you see BGP, EIGRP, this one, locator ID suppression protocol. So we can configure it. This router is supporting that one, LISP. Okay, so what we are saying, this router is supporting that protocol. So first see theory, because we don't have configuration in our syllabus, just we need to understand the concept. So let me show you. First, what we told, why we are using this protocol. This, first of all, we need to remember this protocol, that is LISP, stands for Locator ID Separation Protocol. It is a mapping and encapsulation protocol. Why we are using? Because we have the issue in the internet routing table, because it is growing exponentially. Okay, and it is putting the load on the BGP router. Currently now we have 800,000 prefix in the routing table, that is a BGP routing table, internet routing table. We need more powerful router with enough RAM and TCAM to store all prefix in the internet routing table. And also we need router with the powerful CPU to process changes in the routing table. This we need. And with the traditional IP routing, what we are doing, we have the two function. First one, we are saying identifying the device, and then location. So location, how we are getting? We are getting with the routing protocol. But here LISP is separating these two function. They are saying first one is a endpoint identifier, that is EID, assigned to a host like computer, laptop, printer, anything. Example, we can say Google server. And routing locator. Routing locator is nothing but assigned to a router. We use the RLOC address to reach the EID. If you want to go to Google server, we will check it is connected to which router, and we will reach to RLOC, that nearest router. From there we will go to EID. So what we can say, with this one we can reduce the load from the BGP router, from the internet router. So Cisco created LISP, but it is not a proper solution. It is an open standard defined by RFC. RFC is nothing but research paper. RFC 6830. This is a RFC. If we search in Google, we will get the detail about this one. Originally it is designed for the internet, but nowadays you can also see this on the enterprise network like data center or WAN or campus. We can see this protocol. Now some companies are using this one, but mostly this is designed for the internet. But nowadays in the data center they are using this one. So what is the overview of this one? It is a mapping and encapsulation. And we told in this one we have three things. First one, we are saying LISP side, that is a EID. EID means our device. Example, if you see, this is our device. First thing, we will have our device. Second thing, what we will have? Our site. What is site? That is LISP site. LISP site is this is a EID namespace where EID are. And then we have the non-LISP site, that is a router. So in simple, if I say we have three things, one is our server or our location, another one is the router, another one, the third thing is a mapping server. So whenever we want to communicate, example, if you want to go to host B, okay, I am taking simple example, but this will be in the real scenario, you will have the complex scenario. Like if you want to go to google.com in real scenario, then you will ping, it will come to the router and it will go to the mapping server. From mapping server they will check. Example, if you want to go to host B, where is host B is connected? They will say it is connected to what we can say Y. So where is Y? They will forward to Y. This information go here, they will check here, they will reply back, and he will forward to Y. Y is going to forward there. So this one we are calling EID space, this one RLOC space, again EID space, and this is a mapping system. Mapping system is nothing like a same like DNS. Like before we have DNS, here also we directly we cannot say DNS, but similar work like a DNS. He is going to store which host is connected to which router. So easily we can look here and we will get the information, we will forward the traffic. So if you see here, same thing I mentioned here, we have the mapping server, this one, and this is our device, and this is our router. So this is one scenario, and the other scenario, what I am saying, the our mapping server is nothing but similar to DNS, and it is having the all entry in that one about which device is connected to which router. And if you see, this is another scenario, similar scenario just now what we see. Example, if I want to go to the, what I can say, host B, host A will send the request to this router. This router is going to check with the mapping system. In mapping system we have the controller, they will check everything. At last they are going to reply. When they reply, again they will check, and where we need to go they will forward to that, depending upon where I need to go. Example, if I want to go to B, they will check where is B and how we can go to B. They will check which server is near to him. This is Y, from Y we can go to B. So depending upon that, what we can say, entry, they will forward the traffic. Here I am saying like EID example, this one is a map request, and this is a, what I can say, database is replying saying that if you want to go the device, end device, this one, you need to forward the traffic to the router, this one. Just they are saying, I'm asking if I want to go to this device, how I can go, and this guy is replying, this device is connected to this, so we need to forward to this router. So our router will forward to that one. And this is example just now which we see. So if you see here, same scenario, this EID is sending the packet, it will go to router will send that information to server, that is mapping database, and they are going to reply again back, and they are going to forward depending upon that one, that information, and again it will come here and they will forward to the source. So what they are doing the mapping and also encapsulation. So information is coming here and going here, and they are going to encapsulate, and they will forward here, and again here decapsulate, means they will put this information. If you see, I have here source IP, destination IP, but if you see here, I have extra this two thing. Adding is nothing but encapsulation. If we are adding something to our packet, we are calling encapsulation. If we are removing that that information, any information whatever we added, we are removing that information, it is known as decapsulation. So here we are adding the information, like what we are adding this router information, RLOC information we are adding. We are saying if we want to go here, we need to forward from this location to this location. So that information who give us, mapping database give us, if you want to go to this 2.102, then you need to forward the traffic from RLOC 192.168.123.1 to 123.2. So that information is added. So here encapsulated, and when it reach here, they will decapsulate here, and they will send the original packet. That's why this protocol name is calling mapping and encapsulation protocol. So this way we can forward. Same scenario in the different picture, it will come here, they will check from the database, and then they will forward to the particular location. So this is simple, just we have some basic theory in our syllabus. So we need to remember, first of all we need to remember the full form, and then why we are using this one, what is the issue, we need to remember this issue, and then we need to define. And endpoint identifier is a EID, and the routing locator is a RLOC. Okay, this one. So some data center, mostly in the data center we are using this protocol. Okay, so